we can go ahead and make the game. So in other words, the game cycle. So at the top of your game scene, we're going to make an enum called game phase. So this will allow the program to keep track of what phase the game is in, so that when you touch it, it won't do the wrong thing. So an enum is basically its own type, and it has different cases, and we can call them pregame. Case, in play, and case. So the pregame phase is before the game starts, and our guy is just going to be floating there waiting for you. Our in-play phase will be during the game's play, so while we're playing. The game over phase will be after you got a game over and you're waiting, and it's going to show you all of the stats and your score and everything. And then finally, we're going to have ready to reset phase, because we don't want, because after you get a game over, so as soon as you hit a reef, you get a game over, you don't want it to be able to play the game right away. You want a brief period where you can't touch it and do anything, and you're waiting for it to be ready for you. So that's during the game over phase. So let's fold up all the functions here so we can get a nice big overview. Now let's create functions for every step of the game cycle that can happen. Alright, so right after did simulate physics, we are going to make a function called reset game. So everything in here is just going to be when we reset the game. Then we are going to start the game. That will be called when we start the game. Then during the game, create, reef, repeat will be called over and over, so that's kind of in the correct order now. But then when you get a game over, we're going to call game over. So we're going to get a game over. Oh, and also during the game we're going to have player scores. So we're going to have more things happen along with the scoring. So instead of just scoring here and did simulate physics, we're going to handle that in player scores. And then finally, we are going to display game overviews. Game overviews. Display the game overviews. In our pregame phase, we want a label, a big title label to say the title of our game. Go ahead and copy our score by holding Option and dragging, let go. And now this will say, in our text, we'll make it say Flappy jellyfish. And it's going to say it right there. Let's make it big and bold. Alright. This is going to be called our title label. In our game scene, right under where we declare score label, we'll declare a title label and hook it up to our scene editor in the exact same way. Did move to view, title label equals child node with name, title label. Cast as an SKLabel node. And also, in the beginning, before you play the game, the jellyfish is going to be just floating there. So okay, in our jellyfish class, we want to give it a new method called hover motion. Did our title label show up? Nope. Because I spelt it wrong. It is not total label, it's title label. There's our title. Okay, in hover motion, we are going to give the sprite, or we're going to give the jellyfish, an SKAction, and there are many options to do this. So the last step is to run the action, which takes in an SKAction of whatever type you want. You can move it, you can scale it, whatever. But we're going to declare the action in a variable called move. and that will be an SKAction.sequence, and that's going to take an array of SKActions. So arrays use brackets, so do a open close bracket, press enter so it looks nice. Inside of here we're going to list our actions. So let's say it's going to move up and down. Whoops, move. We're going to say move by 0x and 60 for the y, so make it go up over 1 second, comma, because it's an array, and now it's going to move down negative 60. So it's just going to go up and down, up and down. Now to run this action we say run, and then the action is move, and then it should move. And look, it's moving. It's going up and down. The problem is it's still being affected by gravity, so we can't see it float in midair and do that. So we're going to set gravity, or we're going to set the jellyfish's physics body dot affected by gravity equal to false. So affected by gravity is false. Let's run it and see if it's floating. Okay, we'll come back to this hover motion. What we really don't want to have happen is the reefs come by before the game starts. Alright. So in our game scene, go to touches began. Okay, here we're going to have a switch statement. And what that does is it checks for the value of whatever you put in here, value, and then does different things for each case depending on what the value evaluates to. So we're going to evaluate our game phase. Okay, our very first property of game scene we're going to put before anything is var game phase. So it's an instance of our game phase enum, and it's going to start off in the pre-game state. So now in our touches began, that we're going to evaluate our game phase variable, and in the case that we are in the pre-game, then we're gonna do stuff when we touch it and it's in the pre-game state. Well, we're gonna set the state to, we're gonna say game phase is now set to the in-play state. Default we're gonna break. In a switch statement, if none of the cases are met, then it goes to this default execution in which it just breaks out of the switch statement, but you can put other stuff in there. When you touch and it's in the pregame state, then we call start game. So in our did move to view, remember how we put create reef repeat? Well, we want to take it out of did move to view and put it in start game. So now only when we start the game will we create the reefs. So also when we start the game, now we're gonna make the jellyfish experience gravity. So it's gonna start to fall. So we can set that here. Jellyfish.physicsBody.affected by gravity is now true. And we're not actually calling hover motion, so we want to do that. Okay, and did move to view. Last thing that we want to call is reset game. So everything in terms of resetting the game will be happening in the reset game function here. Now in reset game we want to say jellyfish hover motion. This is going to be a lot of just testing. That's what making games are all about, just making a tweak and then testing it. Oh, that was our hover motion, but it's still doing our hover motion. You see that? Kind of. So we need to stop that action. So go back to jellyfish. Okay, so instead of just calling this move action, okay, we're going to call a SKAction repeat forever action, and in here we'll do a we'll put the move action inside here so it's doing it forever, and then we have to say with key, that's another argument, hover, call it hover or whatever. This way we can stop the action once we start the game. So let's make another method called stop hover. And then we'll say remove action for key, and then we use the same key that we gave the hover action. So where are we going to call stop hover? In our game scene when we start the game. So jellyfish stop hover. Now we have this nice hover effect, just waiting for us to play the game. And we tap, and now the game starts. We start to see the reefs. What should happen? Shouldn't we get rid of that title? Yeah. Okay. So where is that going to happen? Probably in start game. We're going to say title label has a property, and all nodes have a property of is hidden. You want to go ahead and use that. Set it to true. Then think of the opposite of that. When do we want to show it again? Probably when we restart the game? Yeah? Okay, let's do it. So we set title label that is hidden to false when we restart the game. Look at that, we got rid of the label. Now we need to handle what happens when we lose, because now we can never lose this game, no matter how hard you try. In game over, we want to set the game phase to game over. We want to stop the shark timer. We want to stop the reef timer. So we say reef timer dot invalidate. We're gonna give the jellyfish a little spin, so he's just kind of spinning out of control. Nice little touch. So we're gonna set his angular velocity to some random number between -5 and 5. With angular velocity, this is given in radians per second. If you don't know what radians are, pi is 3.14 is a half circle, and 2 pi is a full circle. That's all I gotta know for now. Okay, for now, just to get a nice, just an immediate cycle going on, let's immediately change the game phase to ready to reset, so that touches began. Okay, we're gonna have a case where game phase is equal to ready to reset. So if we touch, colon. So if we do touches begin during this phase, then we're gonna reset the game, and then set the game phase equal to pregame. There's one phase we forgot to do things in, so if the case is that game phase equals to in play, then we'll be able to make the jellyfish jump. So we're just going to take this line here where we make him jump upwards, put it in here, get rid of this whole thing. It happens that we do not need the location of our touches in this entire game. Pretty cool. So we don't even need touches moved, so just get rid of it. We don't even need touches ended. Maybe you can think of a clever spin-off of this game using touches moved, but let me know. So when we reset the game, we want to give the jellyfish just a initial position that it's just always going to start at. Probably a good idea. So its position is just going to always reset to, let's see, 200 over, and then in the middle of the height of the screen. We want to reset his velocity. We want to reset it to 0 just in case he's moving at the time of reset, because we're not making a new jellyfish, we're just repositioning the same one we have. Useful. Since it might be spinning, we want to make it stop spinning. Yeah, angular velocity set to 0, and then it's going to reorient itself to be upright. So that is called z-rotation. Jellyfish.z-rotation is 0, so it is not at any angle. Okay, and just for a nice touch, I think we're gonna make the background different colors each time, and I think in Flappy Bird it does just different backgrounds each game, just to keep the interest up. So let's get a random color. Go to helping functions. Random color, there we go. Alright, put this in there, copy this down as a snippet. Very useful. Okay, so in reset game, we are gonna set background color to random color. Let's organize this better. Put jellyfish hover motion. Put that last. Nice. Ooh, that's a cool color. Be cool if there were some bubbles. Ooh, we didn't actually get a game over. Okay. Alright, in game scene. Okay, look for did begin contact. Now, the whole reason why we did this contact is to get a game over. We're going to make all the reefs stop dead in their tracks. So, in did simulate physics, we're only going to execute this stuff if the game is in the in-play phase. So we check if the phase is in play, and only then will we do this stuff. Because remember, when we get a game over, the game phase is immediately set to the game over phase. In our case, the ready to reset phase. So we're playing, we lose, and everything stops. And we click again to reset. Ooh, what do we need to do? The reefs aren't moving anywhere, so we need to get rid of all of the current reefs. So we'll do that in reset game. Let's do that first. So just like in did simulate physics, we're going to loop through all of the children in the scene that are of type reef system and remove them. So reefs.remove from parent. Nice ugly green. Now I lose. I click. The game is reset. Oh, okay. We need to set the jellyfish affected by gravity to false during the reset. As we lose, click to reset. But look, he's falling. That's why we play test, people. So here, we're doing a bunch of physics stuff. So it looks like a good place to put it. So set its physics body affected by gravity to false. I lose, click, and he's doing his hover thing without falling. Yay! Loving those colors. So there's a problem with me being able to go too high or too low. Let's put something in did simulate physics. So within our in play condition. So this is after all of the reef handling. We can ask if the jellyfish position dot y is less than 0, or jellyfish position y is greater than the width of this, or the height of the screen. So if that happens, we want to call game over. I'm going to go too high on purpose. Oh, and we lost the game. And we lost the game. So now we just need to fix the fact that it's ready for me to play immediately, because we want to have a little wait time. So I lose, click, see how there's no wait time before I could restart the game. And we'll fix that now. Okay, so make a timer. Alright, after 1 second, let's do 2 seconds. We are going to call this once. We're going to execute this once, so this repeats need to be false. We're going to call self.display game over views. Here we're going to set the game phase to ready to reset. Alright, go back to your scene editor because when you get a game over, we are going to show a display that displays our score and our best score. Let's make a color sprite. It's going to be sort of centered here, as centered as you can make it, sort of. So that's the problem with this, you can't really center things too easily, too much. Alright, that's not going to bother me at all. Okay, give it a nice texture. Paper. Uh-oh. That's another crazy thing. Alright. Now we're scaling down the paper texture to what we want. We're gonna have some children of this paper node. So get some labels going. Alright, drag in some labels. And now, okay, well. Alright, we want this label's color to be black so we can see it. Make it medium, bigger. Alright. And this will be called score. And we can make it say score right now. Copy that with a little drag. And we're going to call this best. We can make the text say best. Excuse me. Okay, to make these labels children of this square, is you have to drag them like this in the structure. They're like nested inside of this folder here. So you can move around this with the labels being moving along with it. Alright, let's call this game over display. Back in the game scene. Alright, we're going to have 3 new properties. Display. That's going to be a sprite node. We're going to have, say, game over score. That's a label. And game over best. So as not to confuse it with the score label that already exists. Alright, and we reference the child node with names. So I'm just going to copy this and say, So game over display. That will be game over display with an I. Make sure it's spelled right, and that is a sprite node. Okay, let's take our other ones. Game over score, child node with name, and that was called score. That is going to be cast as a label node. Same with the best. Let's make sure everything's working. Oh, exclamation points. Okay, why isn't this working? Because when you say child node with name, you're really saying self.child node. So these are children of the scene. Remember, game over score and game over best are not children of the scene. They're children of the game over display. So in game over display, that's what we want to say. Dot child node with name. You have to be careful of your child parent tree system. The tree of nodes. Look at that, appearing just as we want. Very not centered or anything. You could certainly center it in code, which is kind of annoying, because that's what the scene editor is for, is not having to do code, but we will. Game over display. Let's put that in the very center of the screen. We can say game over score, position X is equal to game over display. We can set that to 0 because that's in the center. of its parents. Same with best. We can leave the Y's alone. Let's comment what we're doing here. So center labels. Yeah, it looks a lot more centered. Certainly does. Alright, so we don't want to show this in the beginning. So hide it. Okay, game over display is hidden. And we only want to show it down here. So when we get a game over and we say display game overviews, so we want to say display is not hidden anymore. In fact, oops, is not hidden. In fact, we want to hide it in the game reset. So let's put that here. And let's put it here. Okay. So that means we don't need this line here. Okay, now let's tell it what the labels are going to say. Okay. So the score is going to say, well, what your score was. We're going to say score colon and then interpolate the score variable. The best label is going to do the same with the best. Best colon backslash parentheses best. We haven't actually dealt with getting our best score yet, so how about this? Remember we made player scores, okay? So in did simulate physics here where we scored, we want to call player scores and then move these lines to the function player scores. Okay, now we can tell if we've gotten a best score or not. So we're going to ask if score is greater than the best so far, then set the best to the score. Nice. Don't think we need to print anything anymore. Okay. Why isn't it hiding? Okay, in reset game. Oh yeah. We want to set game over display hidden to true. Oh good, it's not there. 1, 2, 3. Huh. There we go. Why wasn't it working before? That's weird. Alright, let's see if I can get a best of 4. Ooh, 5. And lose. Oh, you know what? Score is 5. We're not resetting the score. Go back to reset game. Let's set the score to 0. I'm going to copy this line from when we set the text of the score label to reset game. So the last line will be score equals 0. Set the score label text to that 0. And then everything will be great. One, 2, lose. Why did not do that? Alright, go ahead and set the Z position of the score and best label to 1. Because I think they're just behind the... I don't know. Now, what's the point of the best score if you can't save it? Show all your friends. We have to be able to save it persistently to the hard drive. Now the way to do that with single values is... Okay, right before we reset the game for the first time in did move to view, we are going to put this stuff in here. Okay, this will be for saving. Okay, so to reach down to the depths of the phone data, we say user defaults dot standard dot object and then for key. So we are going to ask for a key. Let's call it best. If it is not empty, if it does not equal nil, then we're going to set our variable to a value. So we're going to set our variable best. Remember best from right here. We're going to set it to whatever this evaluates to. And that's basically going to be what the value is in this key of best. And we have to cast it as an integer. That's how you load data. Saving data. Okay, so make it look nice. Copy that stuff, and now we're going to go down to player scores. Now, whenever we set a new best score, which is in here, we're going to save it. All right. So user defaults.standard.set new value for key best. Okay. And that value will be whatever best is. And then we have to call the synchronize thingamabob, and that's how you save data. Let's test it out. Okay, so let's try to get a best score here. 1, 2, 3. Can he go all the way? Woo! 4. Oh man, got a best of 4. Now let's just test that out here by just playing again real quick and see if the best score stuck. Alright, best is still 4. Now if we close the app, alright, let's just rerun it. Alright, take 2, and we lose right away. Our best is still 4. Look at that. Let's make some sharks. Let's make some sharks as an extra little challenge for the player in case the reefs weren't boring enough. So make a new shark class. It'll be a subclass of SKnode containing a sprite. Just like that. Our sprite node is going to have the image named shark. Give it a size of 240 by 120. Give it a physics body of texture that's going to match the image exactly. About sprite.texture. Easy enough. With the same size as the sprite. Sprite.size. It is dynamic. It will not be affected by gravity. It will not allow rotation. We will get rid of these. Let's go ahead and give it a mass of some big number, because we still want it to be floating around with physics. That's why dynamic is true. But when it hits the jellyfish, I would like the shark to not bounce around. Its category bit mask will be shark. Its collision bit mask will be colliding with type player. And its contact will be with player as well, so we can have the program recognize when they contact and do stuff. Don't forget to name the class shark. In the game scene, just like how we have creating the reefs over and over, we're going to do something real similar with the sharks. We'll call it create shark repeat. And each time this is called, we're going to create a new instance of shark. We're going to position the shark X-wise all the way off the screen and 400 more. We're going to position its Y randomly so as to surprise the player whether it's going to be up or down, and let's have it go between 300 and 300 off the top of the screen. Let's give it a horizontal velocity. Horizontal. That shall be random as well. How about that? So negative value will make it go to the left, so it can go between -200 and -400, and add the shark to the scene. So we're going to call create shark repeat once, and then within the function itself, it will call itself after a certain time. So we want an interval, a time interval, and we're gonna say time interval, and we're gonna have the shark. We're gonna have the interval be different every time within a range. So how about between 10 seconds and 15 seconds? Okay, let's go ahead and make a shark timer in the global area. Put it next to our other timer. Alright, go back down to your create shark. Now here we're going to set our shark timer equal to a timer. Schedule. So that's going to start the timer with whatever interval happens. Repeat is false. And here press enter and then underscore in, and that's where we can call its own function. Okay, we're gonna call shark timer for the first time in reset game, start game. Just like we're calling create reef repeat, we're gonna call create shark repeat. Now we can run it. Where's our shark? There he is. There's a nice little shark. Okay, let's see how long it takes for the next shark to come. Oh no 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 no. Aw. Here's our shark. Now if we touch him, nothing really happened. So we have to make it so we have a game over when we touch the shark. In did begin contact. The same way we had the player in the reef do things when we contact. Same deal with the shark. So copy that, but instead of reef, say shark. Let's make it print you hit a shark. And then we'll call game over. Now the sharks are dangerous. There's a shark. There's a shark. Let's see if we find another shark. I lose. Uh-oh. You know why it's glitching? Because when we contact, we're calling game over every single time it contacts. And we only want to call game over during the in-play phase, right? So we could put one big condition over this whole thing. If game phase is in play. Only then do we want to have the collisions happen. You can dance, you can try, game over. You can try. I gotta find another shark. I got to have another shark. Here's a couple sounds I made. So this is the bloop sound when our jellyfish jumps. Bloop. Here's the smack sound when you get a game over. And what is a nice game without background music? Here it is. Let's put some sounds in our game. Okay, at the bottom of your game scene, you're going to make two new functions, one for sound effects that are short, and another for the background music. It's long and it loops. So in each one we create an audio node, and then we tell whether or not it loops. We add the node just to the scene just like any other node. Then we run an action on it to play. And then for the sound effects, we are going to remove it after 1 second of it playing. So we don't just keep on building more and more nodes to the scene. We want to get rid of them. For our background music, we don't get rid of it. It just keeps playing forever. Now to use these functions, where did we go? Okay, in touches began at the same time as the jellyfish jumping. That's when we call play sound effect, and we reference our sound file. This has to be spelled exactly right, exactly how it appears in the file structure here. When you smack into something in did begin contact, we're calling the play sound effect now with using our smack sound. And then for the background music, we're doing that in did move to view. Right before we reset the game, we call play song looped on our sound file for the background music. Here's the finished product. So polished. That was a lot of stuff to memorize. Jeez. The only way to get better is just do it yourself. Just go create stuff, go be creative, and do it yourself. It's the only way to get better. From now on, in the following videos, I'm not going to stop to explain things. You're just going to have to know it. So get out there and create.